Good evening, one and all present here. Welcome to Protrainy's discussion of IS 456 and IS 13920 for ductile detailing webinar. I am Pallavi, your host for today's session. Let me give you a brief introduction about who we are. Protrainy is an NSR cell IIM Bangalore pre-incubated edtech startup. We are registered with Startup India, Startup Odisha, and OCF. Landing skill requisite, which precisely fit market demand, is tougher than landing a job itself. That's where we come into a play. We prepare engineering students to industry ready by training them for the essential required in the field. We believe that skill building is an extensive process, which require detailed and practical knowledge with the help of our experienced experts. Our only aim is to build a skilled workforce for the civil engineer industry and to create thought leaders of tomorrow. Protrainy brings to you an evolving industry-ready environment to tackle the ever-shifting business scenario. As an educational platform creator, we upskill civil engineers in technical domain as per current industry trends. From theoretical concepts like structural engineering, bridge engineering, to software trainings like Oracle Primavera, ETABS, AutoCAD, we offer 360-degree holistic development required for a civil engineer to become a skilled industry professional. We recently conducted an industry-ready long courses on Primavera, highway engineering, etc. And good result in these sessions has motivated us to go beyond our boundaries and get more for all of you. To be updated with our upcoming amazing courses, please go and follow our Instagram, Facebook, and LinkedIn profile by the name Protrainy. Now, I would like to introduce our expert, Samanas Dimri, who have joined our forces to make everybody industry ready. Now, I request sir to please start with the session. Thank you. Over to you, sir.
Thank you so much. Thank you so much. Could you please enable my screen sharing?
Sir, I have given you the permission.
Please enable at Manas, not Manas Jambi.
Okay, sir.
Did you provide you the permission?
Yes, it's done, sir.
Okay, thank you. Hi, good evening, all of you. So this presentation is regarding discussion of IS 456 and IS 13920 for ductile detailing, as Pallavi already told you about. So for us, ductile detailing is quite an important topic when it comes to reinforced cement concrete, because concrete itself is a brittle material, and the ductile material, which is steel in itself, so an adequate amount of steel and its lapping plays an most important role while coming into the RCC or RCC structures. So IS 456 is an BIS code, which is named as Plain and Reinforced Concrete Code of Practice, which it itself consists of so many clauses and so many formulas regarding. Could you mute someone having a background noise? I think Salman has having a background noise. Yeah, now it's fine. So, hi, Salman. Could you please mute your mic? Okay, so coming on the introduction, so IS 456 consists several clauses regarding formulas and different lapping and design statements regarding RCC. Apart from that, IS 13920 is also a BIS code, which is named as Ductile Design and Detailing of RC Structures subjected to seismic forces code of practice. Since seismic force is itself is a vast topic which need to be covered with different module, and earthquake force is unknown force which can relocate moment and shear force within a structure, and that can lead to collapse of the structure, or several cracks can develop within the structural members. So to withstand such unknown force or earthquake force, we have to have an proper ductile detailing or reinforcement detailing uh, according to the code, so that which it can withstand such kind of a force. See, as you can see in the slide, there are three images. So first images shows three pictorial views of minor shaking, moderate shaking, and strong shaking. In seismology, we called it as IOLSCP, which is immediate occupancy, life safety, and collapse prevention. So it's kind of an advanced thing in seismology itself. Coming to the figure 2, here you can see a red arrow is being dotted over the picture, which shows a shear failure. As you can see that crack is developed at an angle of 45 degree. So whenever there is a shear failure or shear crack, and the angle is most probably about 30 to 45 degree. So this can be lead because of different reasons. Not going into the regions. So this kind of a crack at an angle of 45 degrees is shear failure. At the third image, that is figure 3, as you can see, that there is an collapse of an column, and concrete has been brittled down or cracked and broken down so severely. And in a building, if if column collapse, so structure cannot withstand anymore. So we need to have a better design and better movement capacity of column as compared to beam or other structure members, because load need to be transferred by column itself to the foundation level. So there are general specifications. I have taken few specifications because that would increase a slide size, or that would require more time. So first is minimum grade of structure concrete which need to be taken into account is M20, but M25 for buildings which having more than 15-meter in height in zone 3, 4, and 5, and should not be less than the required grade of concrete as per the exposure condition mentioned in IS 456. Where M20 or M25, the last term shows the last numeric value shows its characteristic strength, and stands for the mix. Coming to the another point is in RC frame buildings, lintel beam shall not preferably be integrated into the column towards short column effect if it is not proposed in the structure drawing. So if you get a structure drawing over the side, and it is not modeled in the structure, that means it is not mentioned in the structure drawing that lintel should be incorporated or integrated into the column. So if it is not integrated in the column in the structure drawing, that not to be done in the site, because if you integrate such a lintel beam into the column, that could have a short column effect, and that short column effect you can see in figure 2, that is which I was telling you some of the reasons for shear failure. That could be a reason for the shear failure. So in mountain areas, short column effect dominant. Coming to the third point, a minimum grade of structure concrete be M20, as I have told you earlier, but depending on the exposure conditions, for mild exposure conditions, it should be M20. For moderate exposure conditions, it should be around M25. For severe exposure conditions, it should be M30. And accordingly, for very severe conditions, it should be M35. And for extreme conditions, like deep sea works, it should be M40. Coming on the next slide. So coming on the beam, so there are several general clauses which are being mentioned in IS 456 and IS 13920. So first clause is, so first point is, beam shall preferably be having width to depth ratio or B to D ratio of more than 0.3. And as we have already studied in our basics of BTech or in diploma or in masters, that beam need to have a greater depth than width. There are several conditions where depth cannot be appropriate and cannot be more than the width. There are several conditions, but preferably we need to have a greater depth in beam rather than the width. Second point is, beam shall not be having width less than 200 mm. And on site, there are very least of least conditions when 230 less than 230 mm of width of beam is being designed. So most of the time, beam are designed with the width of minimum of 230 mm. But as per the code, that can be decreased up to 200 mm. Coming on the another point, beam shall not have depth more than 1/4 of the clear span. So coming on the longitudinal reinforcement, the longitudinal reinforcement in beam shall be given below as, like, beam should have at least of 12, at least of two bars of 12 mm diameter at two at the top and two at the bottom face. So this is the minimum requirement of a beam. Another is like minimum longitudinal steel ratio. There, I think a rho is missing. So rho minimum, minimum ratio, minimum is can be calculated from the formula as it is given, 0.24 into under root of FCK upon Fy, where FCK is the characteristic strength of the concrete and Fy is the yield strength of the steel. Third point is maximum longitudinal steel ratio, which need to be provided at any section of a beam, should be 0.025. It should not exceed this ratio. If you can see the B point in longitudinal reinforcement, there is an image showing like total amount of steel at the steel as per the calculation at the bottom size, and at the above end, like green dots are pointed over it, and it shows bottom steel at support at least of the half of the top, and at the right hand side at least 2 bars should go full length of the beam. So coming on this picture, see, we know that movement in a beam most probably lies at the tension zone, that tension zone can be at the upper end of the beam or the lower face of the beam. In simply supported beam, there is only a situation when tension zone lies at the bottom face of the beam. But in continuous beam, tension zone could be at the top face or at the bottom face. So at wherever is the tension zone, the maximum reinforcement is being provided at the tension zone only. So whatever is the calculation of the steel, that 50% need to be provided at the compression zone, because when load is being provided at the center of a beam, and if it bends, it will curl itself at the column face, and tension zone will get at the opposite face of at the center. If at the center tension zone is at the bottom, then at the column face, the beam part and near to the column, the tension zone will develop at the top and top face of the beam. So that is why 50% of steel which is provided at the compression zone, which whatever amount of steel comes at the tension zone. Apart from that, at least 2 bars should go throughout the column to provide a confinement or proper load transfer mechanism within the column and the beam, which, like, if 2 bars, minimum of 2 bars are there, it can be more than 2 bars. If 2 bars go throughout the column, that itself says it is a continuous beam. And when bar goes continuous throughout the column to the other side of the beam, so this thing creates a mechanism of continuous beam within the column and beam junction. Coming to the next slide. So the longitudinal steel in the beam at any section on top or bottom face shall be at least of 1/4 of the longitudinal steel provided at the top face of the beam at the face of the column. So hello. So longitudinal steel at any section of at the top of bottom face shall be at least of the like, if I curtail a certain amount of steel at any part of the section, so at least it should lie 1/4 of the longitudinal steel which is being provided at the column face of the beam. Apart from that, and like another clause is mm, the reinforcement of the bar which need to be gone into the or embedded into the column, which it should have length of long development length, which is LD, plus 10 into the diameter of 10 into the diameter of the bar, minus the allowances for the 90-degree band, which is 2 times of the diameter. For 45-degree, it is about 1 time of the diameter. So minimum this length of embedment of bar should be there to have a proper load transfer mechanism within the column and beam junction. I have provided certain like a certain development length criteria, development lengths for different bars and the different grade of concrete, considering a constant grade of steel, which is 415 for limit state design at the tension zone and at the compression zone. At the left hand side, it is tension zone, and at the right hand, the compression zone. It is being written in the note. Coming on the next slide, so splicing of a longitudinal bar. Coming on the splicing, So first kind of a splicing which are talking about is lap splicing. So first point regarding that lap splicing would be, when lap splicing is done within a beam, close link should be provided within that entire length, which the longitudinal bar is spliced, as you can see on the figure. The spacing of these links, or you can say strips, shall not exceed 150 mm, because there are two bars are being spliced at that zone. So strips will help to hold that bar and to decrease the chance of shear failure at that location. Because two bars are being spliced at a position, so movement transfer mechanism will not be as good as for a whole length bar. That is why this link space and strip space is being decreased to 150 mm. Another point is the lap length should not be less than the development length, which I have already told you in the last slide, of the largest longitudinal bar in this tension. For an example, if you are using 16 mm diameter and 12 mm diameter at the bottom face, so the lap length should be provided as per the largest longitudinal reinforcement bar diameter, which is of 16 mm. So third point is, lap splice shall not be provided within the joint, or you can say you can see the column face junction, or when beam and beam are joined. So lap splice should not be provided at that locations. Another point is within the distance of 2D from the face of the column. So like here you can say that green dots. So this is the part of the face of the column. So from the face of the column at the distance of 2D, where D is the depth of the beam. So at the distance of 2D, no lap splice need to be provided, because as I've told you earlier, like there is also a chances of development of tension, which is at the opposite phase of the tension at the midspan. Another point is within the quarter length of the beam adjoining the location where flexure yield may occur under the earthquake effect. So while designing a beam, there are several locations where flexure is so high uh, due to the earthquake effect. So we need not to be provide splice at that locations. Coming on the fourth point, not more than 50% of the steel bars on the either top or bottom face shall be spliced at one section. So it is not talking about the number of bars. It is talking about the 50% area of steel. So whatever the area of steel is at a section, the 50% of that area of steel should not, more than that, need not to be spliced at a one section. That cannot, like if you are providing 50% area of steel is providing splice at a one part, so another 50% can be spliced at another section, apart from the three points I have discussed earlier. Coming to the fifth point, bar in a bundle should terminate at different points spaced apart not less than 40 meters from the bar diameter, except for the bundle stopping at the support. So bars should not be terminated at shall be terminated at different positions, should not be terminated at one position, because like if we terminate all bars at one position, then suddenly the load will get concentrated there only, and it would not be able to transfer it properly to the another section. So bar terminations should be in such a way that they are not they are they should be terminated simultaneously, but the spacing between the termination of two bars should not be less than 40 times of the bar diameter. If it is 10 mm of bar, then that space should not be less than 400 mm. Another point is, coming on the another kind of splice, that is mechanical coupler and welded splices. So welded splices or mechanical coupler, there are different way of designing these kind of splices. So while designing a welded splice, we need to consider the clause of steel design. Mechanical coupler are kind of a two threaded hollow sections where bars are screwed within the mechanical coupler. So these kind of mechanical couplers are usually used for bar diameter above 25 mm. Below 25 mm, the bars can be molded or bended, so there is need not to use mechanical couplers. From coming on the points, only those mechanical splice conforming to the IS 16172. There is another IS code for that, and capable of developing the specified tensile strength of splice bar shall be permitted within the distance equal to 2 times of the depth of the member, as I have told you earlier, 2D, from the from the column face or in any location where yielding of is likely to take place. So the spacing between the adjoining adjacent longitudinal bars shall be based also on the outer size of the coupler to allow easy flow of concrete. So like two bars should be spaced in such a way that concrete can be poured while casting a member, and it can be vibrated properly, so and there is no sufficient amount of voids. Another is any section like I have discussed it earlier in lab splice, that and there should not be any section where 50% of area of more than 50% of area of steel of bars is applied at one section. So another point is welding of links, ties, insert, or other similar elements to vertical reinforcement bar required as per the design is not permitted in the seismic zone. So like in seismic zones 3, 4, and 5, welding of links and ties are not permitted because link and ties are the crucial element to bind the longitudinal reinforcement and show better behavior while having shear force. Coming on the transverse reinforcement, or we can say stirrups, in normal practice, a link is made up of single bent bar, or you can say a single bar, but it may be made of two bars also, namely as U-link, as you can say see in figure B. With a 135-degree hook, 135-degree hook is mandatory for a seismic consideration, with an extension of 6 times of diameter, but should not be less than 65 mm. So 6 times of diameter is as per the Indian Standard Code, but if you consider American Standard Code, that would be 10 times of the diameter. So in several books, there it is mentioned as 10 times of the diameter, but as per the Indian code, it is 6 times of the diameter or not less than 65 mm at each end embedded in the core concrete and cross ties. So as you can see in figure A and figure B, figure A is itself a loop of a single bar, and at figure B, it consists of two links. one of cross tie and one is of U stirrup. So these both are combined to form a tie. But most probably we prefer to use a part which is a whole loop of a single bar. If there is no such a condition can be created at a site, or there are several limitations to it, then only U strips are being used. Coming on the another point, the hooks or links and cross ties shall engage around the peripheral longitudinal bar, as you can see in the diagram. Cons- uh, con- con- Consecutive cross ties engaging the same longitudinal bar shall have their 90-degree hook at opposite side of the beam. When the longitudinal reinforcement bar are secured for cross ties in beam that have a slab on one side, the 90-degree hook of cross ties shall be placed at one side. So as you can see in the cross ties, there is a 90-degree hook at the one side. So this point is saying that cross ties will engage around the peripheral longitudinal bar. Consecutive cross ties engaging the same longitudinal bar shall have 90 degree at the opposite side of the beam. So it is the opposite side of the beam. Here 90-degree hook is being provided. When the longitudinal reinforcement is secured with the cross ties in the beam and have a slab on one side, the 90-degree hook of cross ties shall be placed on that side. If there is a slab at that side, then cross 90-degree hook of that cross tie should be placed over the slab, so that a bar can be easily placed. Another point is the minimum diameter for a link shall be 8 mm. Before 2000, it was 6 mm. But now with the revision, it is minimum of 8 mm. Looking at the diagram, as you can see, there are several locations where it has been disintegrated. Talking about at the mid zone, so spacing should be not greater than d by 2, or where d is the depth of the member. So either as per design standard or d by 2. Coming on the side faces, like where 2D is mentioned. So hoop spacing should not be greater than or should be least of d by 2, where d is the depth of the member, 8 times of the diameter of the bar, and 100 which is the least, and the as per the design, whichever the spacing comes, whichever is the least, that least spacing should be used. But keep in mind that links or stirrups shall be start from the 50 after the 50 spacing from the column face. The first link shall be at a distance of not exceeding 50 from the joint face. And another point is being mentioned in the diagram is minimum 2 bar for full length along the top and bottom, as I have told you earlier. Coming on the column and inclined members. So first talking about the general or geometry. So first point is minimum dimension of a column shall not be less than 20 times of the diameter of the bar and 300 mm. So most of the time we use 300 mm, like least dimension of a column is 300 mm. And if diameter of bar is so high, so at that time we can go like cross check it with the 20 time of the bar diameter. So that clause of diameter of 20 times the diameter of the bar, this clause is being provided at the column because reinforcement of beam need to be gone through the column only. So there, if spacing between the bars, longitudinal bar of a column is so less, that can provide so much of conjunction, and this could lead and not proper pouring or casting of the concrete. So avoid such kind of a situation. 20 time of the bar diameter clause has been added in the IS code. Another point is the cross section expect ratio, where expect ratio is the ratio of the smaller dimension to the larger dimension of the cross section of a column of the inclined member, should not be less than 0.45. Another point, if it is less than 45, then then the member should be considered as in wall, not as in column. So please keep in mind, like, why, if you are designer or go to any site, if column and that the aspect ratio is less than 0.45 or 0.4, that should be considered as a wall, not as in a column. Coming on the third point, vertical member of RC building whose cross section aspect ratio is less than 0.4 shall be designed considering beam column joint of moment resisting frame. Like, moment resisting frame is itself as a frame which is predominantly properly designed to resist movement even at the column, even at the columns. Consider second point is longitudinal reinforcement. So talking about the circular column at point one, minimum number of bars should be 6 bars of diameter, not less than 12 mm. Talking of the rectangular column, the minimum number of bars should be 4 bars with bar diameter not less than 12 mm. So from here you can conclude, like, 12 mm is the minimum bar diameter which need to be considered in a column. If you use 10 mm of bar diameter, which is not being provided as per the IS codes. Coming on the third point, lap splicing within the column on the inclined member. So first point is the spacing of these links should not exceed 100 mm. And another point is the lap length, like within the beam, the spacing between the links was 150 mm, and within the column it is 100 mm. So as I have told you earlier, like, column need have better moment capacity than beam, because a crack in a beam can be considered while having severe earthquake, but a crack or a collapse of a column can lead to collapse of whole building. So there should not be any leniency while designing or while casting of a column. Another point is the lap length should not be less than the development length of the largest longitudinal bar in the tension, like, as this same point is also in the beam. Third point is splice shall be provided only in the central half of the of clear column height and not within the joint or within a distance of the 2D from the face of the beam. So if we will move further, I'll show you with the diagram as well. Not more than 50% of the area of steel shall be spliced at a one section, same as of beam. Lap splice shall not be used for bars of diameter larger than 32 mm, for which mechanical splicing shall be adapted or mechanical coupling shall be adopted. Coming on the transverse reinforcement or ties, first point is transfer shall be consist of closed loops. First, for spiral or circular links, circular link in the circular columns, rectangular links in the rectangular column, or square links in the square column. In either case, the closed link shall have 135-degree hook ends and with an extension of 6 times of the diameter and not less than 65 mm at the each end. As I have told you earlier, like 135-degree angle is mandatory while considering the seismic considerations. And the third point is the minimum diameter permitted at the transverse reinforcement bar is 8 mm when diameter of longitudinal bar is less than or equal to 32 mm. If it exceeds 32 mm, then the minimum diameter for transverse reinforcement is 10 mm. Coming on the another point, the maximum spacing of parallel legs of links shall be 300 mm center to center. As you can see in the diagram, there is a figure A and figure B. So in figure B, there is a link being provided at the intermediate at inner like in between of the column. So from the outer and like outer reinforcement and the distance of that intermediate link, that distance should not exceed 300 mm. Another fifth point is a cross tie shall be provided if the length of any of the link exceeds 300 mm. Like it is a cross tie is being provided at a distance of 300 mm because if we will not provide the cross tie, the distance between the links will exceed above 300 mm, which cannot be permitted. A zoom portion has been shown where H shall be larger of HC and BC has been written. Like here you can see that 135-degree of an angle which been provided with at the hook end. So that is mandatory. The hook length should be around 60 and or 65 whichever is greater. As I have told you earlier, like if you consider the American codes, it is 10D, but as per the Indian codes, it is 6D. Coming on the another slide. So spatial confining reinforcement. So confinement is confinements are confinement are the zones where there are confinement intervals are provided to to show proper load transfer mechanism within the beam and the column. So at the right end, you can see a whole column with two beam junctions. So at the beam face, from the beam face at a distance of 2D from the beam face where blue is in marked, at least the transfer reinforcement has an distance as an spacing of either the dimension of the column or HC upon 6 or 450 mm, whichever is less. From the beam face to a distance of HC upon 4, where HC is the column height. So HC upon 4, their spacing of ties should not be more than the dimension of the column upon 2 or the 50% of the dimension. At the central part, not at the central part, at the where there is a lap splice being provided, the spacing between the transfer reinforcement shall not be greater than d by 2 dimension of a column upon 2 or 150 mm, whichever is less. And as per the code, it is 100 mm. So these need to be considered. If these are considered, then a column reinforcement can be called as in confining reinforcement. At the left hand side, you can see like column reinforcement as embedded within the footing. So that shall be extended at least of 300 into the footing or the mat. So, and this discussion regarding IS 456 or IS 13920 that can help site engineers while visiting a site, or if work is being done at a site, they can supervise it. Site supervisor can also take advantage of these kind of clauses and this kind of points. Billing engineer can also cross-check different kind of designs and different kind of executions while making a bill. Design engineer, it is like the far most important part for a design engineer, because for a design engineer, he or she have to detail each and everything while designing it. So they need to know all the clauses. There are further more things within the IS 456 and IS 13920, which I cannot cover within this 1 hour duration of time. So this is for 9. Thank you. If any queries, anyone can ask. If any queries, anyone can ask. Shall I close the meeting here?
Thank you, sir. Now I would like to share one introductory video of Protrainy. So everyone, please look into the video just. वहीं जाके
Yeah, Pallavi, the sound is not there.
Sorry, is it not audible?
Yeah, it is not audible. Can you please connect the audio also?
Is it now?
No. Actually, there would be an option while sharing in the Zoom, right? Share audio also. So just check.
Now?
Yeah, audible.
Okay, I'm
Start.
starting again.
Yes.
So thank you, everyone. Thank you for joining the session. I hope that this session was knowledgeable and helpful. Thank you, sir, and thank you, everyone. And people, those who have not put their name and email ID in the chat box, please do that for certificate generation. Thank you, everyone. Good night.